Hello students, how are you? Dear students, in previous video we discussed balance equation, some information, and today our topic is earliest empirical evidence. So near the end of the 18th century, two laws about chemical reaction emerged with referring to the notation of atomic theory. The first was the law of conservation of mass formulated by Antonio Lavoisier in 1789, which stated that the total mass in a chemical reaction remain constant. That is, the reactant have the same mass as the product. It means if any types of reaction, before reaction and after reaction, the masses value are equal. For example, in calcium carbonate, so this calcium carbonate formation with the help of when quicklime means calcium oxide and carbon dioxide are combined. So when quicklime means CaO and carbon dioxide CO2. So according to their masses of calcium oxide, oxygen and carbon. So calcium here one atom are participate in the mass value is 40 and oxygen one atom are participate in the mass value is 16. So 14 plus 16 equal 56. And as usual the second reactant is carbon dioxide CO2. So when one carbon and two oxygen. So one carbon the mass value is 12 and oxygen 2 atom. So that means the mass value of oxygen is 16. So 16 into 2 equal 32. So 32 and 12 equal 44. And before the first reactant value is 56. So 56 and 46, 44 equal 100. And after that reaction it's formed CaCO3 means calcium carbonate means 1 Ca means calcium and 1 carbon and 3 oxygen atoms. So 1 calcium means 1 carbon one calcium atom means that mass value is 40, 1 carbon means the mass value is 12 and 3 oxygen that means 16 into 3 that it means 48. So 48, 40 and 12 equal 100. So before reaction and after reaction the masses value to this equation is equal. So this is the law of conservation of mass. So conservation it means save to use in future. Okay, so this law represented by Lavoisier in 1879. And according to this law, in experimental, if any types of activity done in a lab, suppose if any types of substance we burn in the presence of oxygen, so before reaction, the apparatus and the product and oxygen means the second reactant. If we calculate and we react to these types of substance, and after reaction, we collect the ash of the product which are burned and smog also. So when we this value are calculated, so both types of substance before reaction and after reaction the value are similar. So this is the law of conservation example for experimental side. And the second was the law of definite proportion, first proven by the French chemist Joseph Louis Proust in 1799. And this law states that if any compound is broken down into the constituent elements, then the masses of the constituent will always have the same proportion regarding of the quantity of source of the original substance. It means if any types of things before we use or after we use, that means if any types of chemical substance or any types of compound these types of compound is not depend to the depend not depend to the sources or places to change the formula, chemical formula. For example, water. So water, if any types of places like that in our district or state or our country or other types of country, and also sources like that river, ponds, lakes, ocean. So any types of places or any types of sources, the water contain the water chemical formula is always same, H2O. So according to their number 1:8, because oxygen, hydrogen atomic number 1, and oxygen atomic mass 8, sorry, number, and atomic mass of hydrogen is 1, and atomic mass of uh, oxygen is 16. So the ratio is always fixed, they cannot change. That means in our country the water chemical formula, one molecules of water is H2O. So another types of country also the one molecules of water is H2O. So this is not depend to the places, when places is changed to change the chemical formula, and also the sources. Suppose in river water, so river water the chemical formula is H2O, and also ocean or sea the chemical formula of H2O. So this is the law of definite proportion of law of constant proportion. So this types of law represented by Joseph Louis Proust. And next, John Dalton studies and expanded upon the previous work and developed the law of multiple proportion. So if two elements can together form more than one compound, then the ratio of masses of the second elements which combine with a fixed mass of the first element will be ratio of small integers. For instance, browsed the studies in tin oxide and found their masses were either 88.1% and tin is 11.9%, and oxygen or 78.7% tin and 21.3%. So oxygen, these were tin oxide, second oxide, and tin dioxide. So Dalton noted from this percent that 100 gram of tin will combine either when 13.5 gram or 27 gram of oxygen. So 13.5 gram and 27 forms a ratio of 1:2. So Dalton found an atomic theory of matter could elegantly explain this common pattern in chemistry. So in the case of Proust tin oxide, one tin atom will combine with either one or two oxygen atoms. So this is the some information of chemical combination, and next video we discuss some other types of content of this chapter. Okay, thank you.